So now we are going to take up this question number 7. So we have this system of equations and we have to determine whether the origin is spiral source, spiral sink, etc., and natural period of the oscillations and natural frequency and some other stuff. Okay, so this time I'm not going to use the equations editor in Blackboard, but I'm just going to go ahead and work with something that I'm more comfortable with. So, and you can do the same thing as I told you, in the videos. So here I'm going to do this first, that is find the eigenvalues as you do in such cases. Okay, so we got 6 minus lambda, -1, 5, then we have 4 minus lambda, and this equals 0 is going to give us the eigenvalues. All right, so there we go. So if we expand it, what do we get? We get 6 minus lambda, right? Okay, and then we get 4 times 4 minus lambda. Okay, so 4 minus lambda, and then plus 5 equals 0, and this is going to tell us that if we FOIL these together, what do we get? We get lambda square, right? Okay, minus 10 lambda, okay, and then plus 24, and then plus 5 equals 0. So what does this give me? This gives me that all this plus 29 equals 0. Then we can use the quadratic formula. Okay, oh sorry. Okay, so we have, if we apply the quadratic formula, let's just put a proper connective here. Okay, then -10 is +10, then we got plus minus a square root of -10 squared is 100, and 29 times 4 would be 100 plus 16, so 116 divided by 2. So we got 10 plus minus, okay, square root of -16, that's going to become 4i. So our eigenvalues are going to be 5 plus minus 2i, right? So this part is positive, so that tells us that the origin is a spiral source, right? And the period of the oscillations is going to be 2 pi, then divided by the coefficient of I, that is pi, right? And then the natural frequency would be the reciprocal of the period. That's going to be 1 over pi, right? So we can enter these values there in the answer box. All right. So now to get the solution of an initial value problem that they propose, what we have to do is first we have to find eigenvectors of these, and in the complex case, just finding it for one of them is enough. So we would do this, that is take up the matrix, and here for lambda we are going to substitute. So let's find it for 5 plus 2i. So we got 5 plus 2i, right? And here also I would do the same, and let's let uv be an eigenvector, right? So what we will have to do is that we will have to solve this equation. So we got 0, 0 here, right? Okay, and so then going further down, we have simplify this thing. Okay, so you get 1 minus 2i, then -1 minus 2i here, So you can see this here, just taking up one of these will be enough, right? So you have what you have, 1 minus 2i times u minus v is 0, okay, and which gives us what? That v is 1 minus 2i times u, okay, and that will give me what? That will give me the many vectors for the, for eigenvector, rather an eigenspace. Okay, so we have this, then we got this here. So we got u, and for v we are going to write this. So we can factor u out. All right, let's do so, or factor the u out, right? And then we got what? 1, and here we got 1 minus 2i. So that's an eigenvector. So what a solution would be? I'm not writing yt here formally. We will write it later. So we got this times t, okay, and this is an eigenvector. So we will write it down, and then that equals, let's factor the first one. So we got e to the 5t times e to the 2ti, okay, all right. So this is, so we got this here, and then we can further expand it by using the Euler's identity. And what shall we get is, we will use the Euler's identity here. So we get what? We get cosine of 2t plus I sine of 2t, right? So are we good? So let me take that in the next line, okay? All right. So here we go. So we got this, and this, when we multiply this out, this would be e to the 5t, and then what we have, then we got this quantity times how much? Simply 1, and then we have a product of these two quantities. Let's write them down. Okay, so we got this, and then 1 minus 2i. All right, so going on to the next step, we have e to the 5t. Okay, let's just go ahead and simplify this second element here, and you know what we are going to do, that we shall see the real part and the imaginary part, and those two parts turn out to be linearly independent, so we shall get a solution if you recall the procedure. So first let's write the real part. So first what we get cosine 2 times 1 is simply cosine t, cosine of 2t I meant, then I times sine of 2t, then multiplied by negative 2i, I square being 1, that will give us how much? 2 times sine 2t. Let's put this in parentheses, even though we don't have to, okay, and then plus, we'll just write the coefficient of I here, what that will be. First we will get negative 2 cosine t, so we got negative 2 cosine t, and then we will get I sine 2t, not t, 2t here, then we get plus I sine 2t, and so negative 2 sine 2t plus I sine 2t, that's what we have. So now we can go ahead and split the real part and the imaginary part, right? So here, this is the real part here, and I made a typo, didn't I, in a hurry? Okay, so we go here, sorry about that. Okay, and then we got this right here, then we have plus. Now we are going to take, see, so this in the next one, this Next step, I will be a common factor, so let's take this out. All right, so e to the 5t, and then we will write the other vector as upstairs here. We get sine of 2t, right? And then what do we get? We get this here, negative 2t sine 2t, right? So what this gives us is that this vector here and this vector here are two linearly independent solutions, and that's all we needed to describe a general solution. So we got yt equals, what we will do, simply c sub 1 times this quantity, right? Then plus c sub 2 times this quantity, right? Okay, and I think I have messed up somewhere right here. I did, didn't I? So I got e to the 5t, right? Very good. Now let's go ahead and recall what the initial condition was. So I'll go to this, and they have given us an initial condition somewhere. Where is it? Right here. Y at 0 is negative 2 and 8, right? Okay, so we have y at 0 equals negative 2, 8, and that will help us do what? That will help us solve for the values of these constants for that particular solution, right? So if we put t equals 0 in here, in y, what would we get? We will get c1, right? And then we get, what do we get for this one here? We'll get 1 here and a 1 here. So we got c1, 1, 1, plus, then what we have? Then we have c2, okay? And then we got what? Then we will have sine of 2t is 0, right? So we have 0, negative 2 here, and that whole thing becomes what? Negative 2, 8, right? So what this gives us is, oh, this turns out to be lucky, okay? And I would not make the things complicated on the exam. Okay, so c1 is negative 2, right? And then the second row gives us the this equation. Let me just write it here just to save a space. Rather, minus 2c2 equals 8. And what will that give us? c1 being negative 2. Negative 2c2 will become negative 2. Let's transfer it to the right hand side. That will be 10. So c2 is going to be what? It's going to be negative 5. So what is our particular solution? Our particular solution is, okay, that is this would be negative 2, okay, and c2 is negative 5, right? And now they just want you to give the first and the second rows for t equals a specific value. You can just substitute that in your calculator and enter it there, okay? So actually, let me not leave it incomplete. So we'll just go ahead and enter it in our calculator, and we shall put the final values in, okay? So what we got is, I'm just going to do this. I'm going to multiply these quantities in, okay? So when we enter them in the calculator, life will be slightly simpler, okay? And then we got plus, and here what we got, minus 5, and this will be plus 10 cosine 2t, and this would be minus 5, right? Oops. Now we get our calculator here, making sure we are in radian modes. We are, right? So the first row, because they want the x1 and it's not x1 what it was. Let me just go back and check. So yes, they want the first row for pi over 10, then the second row for pi over 10, right? So what we would do is -2 cosine of, so we will have 2 pi over 10, that will be pi over 5, okay? Then here we get -5 sine of, then again 2 pi over 10 would be pi over 5, so we get second pi over 5, okay? And we have to make sure we multiply it by e to the power what's that, 5t, right? So that will be 5 pi over 10, that is pi over 2, right? So that is -21.92. So we shall enter that value in the answer box there, okay? And then for the second row, I am being tempted to just ask you to do it yourself, but I mean, you will do it yourself, but anyways, so it's the same thing. 2t would be pi over 5, right? Minus 4 times sine of again what? 2 pi over 10. Oops, sorry about that. 2 where is pi over 5, right? Okay, then we get this stuff from here. Oh, we could have simplified them there, but okay, that's all right. I think this will save more time. So pi over 5, right? And then -5, where is sine? Pi over 5, okay? And then we got this, and we will multiply it with who? Oh, not this, sorry. With e to the power 5 times pi over 10, that is again how much? E to the pi over 2, right? So our y value would be 5.69, and so we'll enter those values, and what I would do is that I shall save this as a file. So I'm saving it as a PDF file. Okay, where did it go? Right here, okay, on the computer. So let's go spring 2020, and this is what, 7 on the exam, right? So it's saving it, all right. Okay, so here we are, and let me go back to my answer canvas. So say we entered all the values, okay, and this time I did not use the text box. So what I would do is that I'm using this, and you can see everything that I do in here, or many things that I do in here. So here I said 7 exam, all right, and then that will just attach it in this portion on this option, okay? So